we'll see the next question. Question number 5. What will come in the place of star in the number 328-4 if it is exactly divisible by 12? So we'll see the working. So here the divisor is 12 and we have to find the number so which suits in the place of hash so that it is divisible by 12. So now splitting this number into two relatively prime products, so it is 3 and 4. So if we check the given number, if it is divisible by 3 and by 4 both, so then it is divisible by 12. So the number given is So for this type of questions, we can proceed from the options. So we have the options 7, 4, 8, 3 and 6. So this number should be divisible by both 3 and 4. So first we'll check for 4. So for a number to be divisible by 4, the last two numbers should be divisible by 4. So when you check the options, these two options are ruled out. So you can have either 4 or 8 or 6 in place of hash. So now test of divisibility for 3. Sum of all digits should be divisible by 3. So the numbers we have 3 plus 2 plus 8. So that hash has to be found. So remaining number sum comes to 17. So with this 17, so if you replace that hash with 4, so you get the sum as 21. So if suppose you replace with 8, so it is 25 and it is 23. So the hash can take the value 4 so that this 21 is divisible by 3. So the answer is 4. So then the given number 328 and now replacing hash with 4, 4 and 4 is divisible by 12. And answer for question number 5 is option B, 4. And the workings are as follows. So we'll see the next question, question number 6. Find the remainder when the product of 2326 and 4889 is divided by 25. So we'll see the working. So we'll see a small example here. Say to find the remainder when 36 is divided by 5. So we know that when we divide 36 with 5, so remainder is 1. So suppose if this is split into 9 into 4 and then divided. So this is remainder of 9 divided by 5 into remainder of 9 divided by 5 and remainder of 4 divided by 5. So when you divide 9 with 5, remainder is 4, and when you divide 4 with 5, so as already 4 is lesser than 5, remainder will be 4 as such. So you have 16, the product, so which when divided by 5 again remainder is 1. So when you divide a number on the whole, the remainder got will be equal to the remainders when it is split into products and found. So using the same technique, we can work out this question. So here the given number is 2326, so into 4889. So we are asked to find the remainder when this is divided by 25. So we can find the individual remainders and then find the product. for a number to be divisible by 25, the last two digits should be either both 0 or 25 or 15 or 75. So it is enough if the last two digits are in this pattern. So we have the number 2326. So this is 1 more than 25. So remainder will be 1. So here the nearing number is 75 and this is 14 more than 75. So the product is 14, which is already less than 25. So remainder for this product divided by 25 is 14. And answer for question number 6 is option B, 14. And for a number to be divisible by 25, the last two digits should be 00 or 25 or 50 or 75. Question number 7. Which of the given numbers is divisible by 36? So now we will see the working of question number 7. So before working out this question, we will see what prime and relatively prime numbers are. So for a prime number, it should have exactly two factors. So if it has exactly two factors, then it is considered as a prime number. Otherwise, it is a composite number. So the two factors are, one factor is 1 and the other factor is the number itself. Say for example, when you take 7, so factors of 7, 1 and 7 itself. So 7 is a prime number. Say for example, if you take 9, so factors of 9 are 1, 9 and also 3 is a factor of 9. So you have more than two factors. So 9 is not a prime number, it is a composite number. So when you check for 1, factor of 1 is 1 itself. So 1 has only one factor. So if it has two factors, it is a prime number, and more than two factors, it is a composite number. So 1 is considered neither prime nor composite. So now we'll see what a relatively prime number is. So in our question, this question number 7, we have the divisor 36. So you have to check the given number if it is divisible by 36. So we'll write down all the factors of 36. So 36 can be got as multiplying 1 and 36, or it can be got by multiplying 2 and 18, or 3 and 12. So one more pair of factors, 4 and 9. So to check whether the given number is divisible by 36, you have to split this number into relatively prime factors. So here 1 and 36, so you have 36 itself. So when it is 2 and 18, so you have common factor 1 and 2. So if it is 3 and 12, you have common factor 3. So for 4 and 9, there are no common factors. The only common factor is 1. So if the only common factor is 1, or if they have no other common factor, the numbers are considered to be relatively prime. So we'll check for 4 and 9. So factors of 1, 2 and 4, and factors of 9 is 1. So other than 1, you don't have any common factor. So 4 and 9 are considered as relatively prime. So we'll split this 36 as 4 and 9, and using the test of divisibility which we have seen before, so we'll check whether the given number is divisible by 4 and the number is divisible by 9. So if the number is divisible by both 4 and 9, so then the given number is divisible by 36. So again, proceeding from the options, So the divisor is 36. So we again split this into relatively prime products. Proceeding from the options, so we have the numbers 2, 3, 4, 6, 9909, 2704, 4518 and 3708. So we have to check 36 divides which of this following number. So as product is 4 and 9, so this number should be both divisible by 4 and 9. So we know that for divisibility of 4, the last two numbers should be divisible by 4. So according to that, when you check the options, the 46 is not divisible by 4, 9 is not divisible by 4, 18 is not divisible by 4. So ruling out this, eliminating these three options, we can check with the other two options. And for 9, sum of digits should be divisible by 9. So when you add this digits in this number 2, 7 and 4, so it is 13. And in this digits it is 18. So the number which is divisible by 36 is 3708. And answer for question number 7 is option E, 3708. So we have to check test of divisibility both for 4 and 9 to be divisible by 36. For 4, last two digits should be divisible by 4, and for 9, sum of all the digits should be divisible by 9. So we'll see the next question. Question number 8. A boy, instead of multiplying a number with 5 by 3, divided it with 5 by 3. So difference in the answers got was 32. Find the number. So let the number be n. So instead of multiplying this with 5 by 3, so this number was divided with 5 by 3. So which implies, so the number is multiplied with 3 by 5. So the correct operation is the number is multiplied with 5 by 3, but it is multiplied with 3 by 5. So the difference in answers is given as, so the difference is given as 32. So it is 5 by 3 times of n minus 3/5 of n, so is equal to 32. So to find the number, so now subtracting these fractions, so using this pattern, so 25 minus 9 by 15 is equal to 32. So which is equal to 16 by 15 times of n equal to 32. So 32 into 15 by 16. So the number is 30. So but for this wrong calculations, instead of doing all this, so to find the number, so which we get the same thing. So you write difference in answers by difference in the multiplicand. So it is multiplied by 3 by 5 instead of 5 by 3. So which is equal to 30. And answer for question number 8 is option D, 30. And the shortcut here is to find the number. So difference in answers is divided by difference in multiplicants. So we'll see the next question, question number 9. So simplify the fractions 1 by 12 plus 1 by 20 plus 1 by 30 plus 1 by 42 plus 1 by 56 plus 1 by 72 plus 1 by 90 plus 1 by 110. So we'll see the working. Here the question is, so here when you check the denominators of these fractions, so here we have 12, 20, 30, etc. So this 12 is product of 3 and 4, and 20 is product of 4 and 5, 30 is product of 5 and 6, and it follows the same pattern. So here the pattern is the denominators are product of two consecutive numbers. So this 1 by 12, so where 12 is product of 3 and 4, we rewrite this fraction as 1 by 3 minus 1 by 4, so which again when subtracted, so 4 minus 3 by 12 is equal to 1 by 12. So this consecutive numbers fraction, so when you subtract, you get the same 1 by 12. So rewriting all the fractions, so instead of 1 by 12, it is 1 by 3 minus 1 by 4. So for 20, it is 1 by 4 minus 1 by 5. And 60 is product of 5 and 6. 1 by 5 minus 1 by 6. And 46 into 7. 56, 7 into 8. And 82 is 8 into 9. 90 is 9 into 10. And 110 is. So this continued addition, when you check, all these terms gets cancelled and will be left out with 1 by 3 minus. So this is 1 by 10 minus 1 by 11. So all the fractions gets cancelled up to 1 by 3 and 1 by 11. So now just this difference will give you sum of all these fractions. So following the same pattern, it is 11 minus 3 by 11 into 3, 33, or 8 by 33. So sum of these fractions is got as 8 by 33. Say suppose we get this type of question, say if the first fraction is 1 by 6 and then it is 1 by 12 up to 1 by 90. So here it follows the same pattern, 2 into 3, and this is 3 into 4, and the final one is 9 into 10. So instead of doing all this, take the first fraction and the final one, and this difference will give you the sum. So it is 5 minus 1 by 10. So this is another example. So instead of proceeding all this, take the first fraction and the last subtract will give you the answer. And answer for question number 9 is option C, 8 by 33. And the hint here is the fraction 1 by 12 is split into consecutive products. The fraction 1 by 3 minus 1 by 4. So we'll see the next question. Which of the following number divides 85,764 exactly? So the given number is and the options are, so which number divides this? 8, 9, 33, 12 and 15. So for a number to be divisible by 8, the last 3 digits should be divisible by 8. So as the last 3 digits are not divisible by 8, so we can rule out this option. So for 9, sum of all the digits should be divisible by 9. So when you add all the digits, so the sum got is 30. So 30 is not divisible by 9. So this option is ruled out. So for 33, it should be divisible by 3 and 11. So sum of the digits we get as 30, so that is divisible by 3. And to check for 11, so the numbers in odd places and sum of numbers in the even places. So finding the sum, so this difference, the sum of the numbers in odd places and sum of numbers in even places difference should be equal to 0 or multiples of 11, but we have here 8, so the number is not divisible by 33, and it is not divisible by 15 because the last digit is 4. So the sum of the digits is 30, so it is divisible by 3, and also the last 2 digits 64 is divisible by 4. So as for 12, 3 into 4, so both the numbers divide 85,764, the answer is 12. So in these options, 12 divides this number exactly. And answer is option D, 12. And as the sum of all the digits are divisible by 3 and last 2 digits are divisible by 4, the given number is divisible by 12.